In this presentation, we are going to discuss on 2 variable and 3 variable K-maps. This presentation is actually the continuation of the previous presentation, and the link is given below. So if you have not seen the previous presentation, please watch it and come back to the presentation, or you can continue with the presentation if you want. So in the last presentation, we stopped with grouping of a 2 variable K-map. So we didn't say that grouping of diagonals is not possible, but still it is possible. So we can follow a question here. So this question is nothing but f of a comma b summation 0 comma 3, right? So m stands for min terms. So there are 2 variables here given in the question. So the size of the K-map will be consisting of 4 cells, just like this. So I can draw a K-map like this, and this is an example of cross mapping A, B, right? So we'll change the color, and A can be 0, A can be 1, B can be 0, and B can be 1. And you can fill up this K-map using the min terms, so 0, 1, 2, and 3, right? So you have to fill up the K-map with ones or prime implicants as given in the question, so 0 comma 3. So put 1 in the place of 0, min term 0, and in the place of min term 3 you can put a 1, because these are the 2 given in the question. Now you can see these are in the diagonal position, you cannot group them. So as far as the K-map rules are concerned, you can see that the groups can be the ones can be grouped if they are adjacent to each other, not in the form of a diagonal, right? So we can form a truth table like this for A and B, and the output can be X, right? For the 2 variables A and B, the possible combinations are 0, 0, 0, 1, 1, 0, and 1, 1. So you have to find the value of X here. According to the question, you can see that there is a weightage given for the position of A 0 and B 0, right? That is 1, right? You can put X as 1 here, and for 0, 1, the position of A and B, there is no value. For 1, 0, there is no value. So simply put 0 for that also. The last one you can see 1 for A and 1 for B, right? So in the truth table you can put 1, right? So this is how we can form a truth table using this K-map, because we cannot group it since there is no adjacent ones, right? So we can form an equation x is equal to for x the values of A will be, first initially it will be 0, 0, right? We can write 0, 0 here because we have 1 here, 0, 0. In the place of 0, 0 you have a 1, so that is seen in the K-map. And in the place of 1, 1, A is 1 and B is also 1. In the place of this we have a 1 in the K-map, right? So you have to convert these ones into ABs, right? If it is 0, you have to put A bar, and if it is 0 for B, you have to put B bar, right? So complements. So for 0, 0 it is A bar, B bar. For 1, 1 it is AB. Now you can see that this expression is very similar to a logic gate that is very famous, right? So this expression is nothing but the expression of a exclusive NOR logic gate, right? Exclusive NOR, right? So you can see A XOR B whole bar. So if it is A XOR B, it is XOR. If it is A XOR B whole bar, it is XNOR, right? So this is the truth table of a XNOR logic gate, right? So if you ever see this in a gate exam or any competitive exams, you can come to the conclusion that this kind of grouping deals with XNOR operation, right? XNOR. So if you see this in any choices, right, in a multiple choice question, you can come to the conclusion that that is XNOR. Now we can go with a 3 variable K-map. We can study 3 variable K-map using 3 variables ABC. Let them be ABC. You can put X, Y, Z, P, Q, R, whatever you want. So there are 3 variables. The size of the map will be, size of the map is equal to 2 power 3, that is equal to 8 cells, right? So you can draw the K-map like this. You can draw this can draw a K-map, you can put it like this. Even if you can put it vertically, no problems. But if you put it horizontally, you can see the things visually very clearly. So you have to draw a long rectangle and split it into 8 equal cells. So you can name it A, the most significant bit, and BC. Right, A can be, I'll just change the color, please wait. A can be 0, A can be 1. And in the case of BC, you can see this. If there are two variables, you will usually do this as 0, 0, 0, 1, 1, 1, 1, 0, and 1, 1. Right? This is what we usually do. But in the case of K maps, what happens is that the last two places, right, 1, 1 and 1, 0, places are swapped. Right? So 1, 1 takes the place of 1, 0, and 1, 0 takes the place of 1, 1. Both of them are swapped. I'll tell you why. In the first position, you can see it is 0, 0, and in the second position, you can see it is 0, 1. The 1 bit has been changed, right? Go to the third position and you can see the 1 remains unchanged and the 0 has been changed to 1, right? So the last position you can see 1, 0. So only 1 bit change is allowed when there are two variables involved, right? So you have to put 0, 0, 0, 1, 1, 1, and then put 1, 0. Right? So this is how mapping is made with a 3 variable K map. So what do you fill inside this? Usually we will fill inside the K map with min terms and max terms. Let's see how we can fill with min terms first. And if there are 3 variables A, B, C, right? So the possible combinations of zeros and ones will be, there are 8 possible combinations will be there. So 0, 0, 0 will be M0, 0, 0, 1 will be M1, and 0, 1, 0 is M2, and 0, 1, 1 will be M3, and 0, 1, 0, 0 will be M4, and 1, 0, 1 will be M5, and 1, 1, 0 will be M6, 1, just a minute, 1, 0 will be M6, and 1, 1, 1 will be M7. So using this, we'll fill the K map, the 3 variable K map actually, 0, 0, 0 of ABC. So all zeros meet here in this cell, put it M0, right? And the next one will be 0, 0, 1. 0, 0, 1 meets here and it is M2. 0, 1, 1. So where is 0, 1, 1 in the table? 0, 1, 1 corresponds to M3. 0, 1, 1. So that is M3. So put M3 here. And the next one is 0, 1, 0. So 0, 1, 0 stands for M2. Right? 0, 1, 0 stands for M2. Put M2 here. And next one is M4. 1, 0, 0. So 1, 0, 0 stands for M4. And then put M5, 1, 0, 1. So once you finish doing this, you'll be very comfortable in solving problems, right? So if you fill the K map with the proper min terms, then half of the problem will be solved, right? So you'll be very confident in solving problems. So in the next video, we'll be solving problems actually. In this video, I have shown you how to form groups and how to write the min terms. So this is how you do it. So these are nothing but min terms. The same with max terms also. Right. So let's see how to solve the groupings. Right. So M0, M1 in some textbooks they will be giving 1, 2, 3, 4. Right. So we'll go with the grouping. Right. How to form the groups. For example, if there is a prime implicant in M1, M0, and there is a prime implicant in M1. There is one in M7 and M6, right? So all you have to do is to group them like this, right? So name your groups. So we'll solve this problem in the next video. In this video, we have just seen how to form groups, right? So we'll solve later. So how to form groups? So for example, I'll show you a special combination of groups. If there is a prime implicant in M2, right, you can form groups like this. So M0 is equal to 1 and M2 is also equal to 1. If the rectangle can be folded, right, M2 and M0 will be overlapping. You can form groups like this, M2 and M0, right? You can form a group like this. So M0 plus M2, this forms a group, right? So here you can see if there is a prime implicant in M3, you can form a group with M7 because they are adjacent, right? M3 is equal to 1, M7 is equal to 1, right? So you can form group like this, adjacent groups, right? Or you can form a group directly, right? I've just shown you different forms of groups, right? So you can form a group like this, and uh, one more combination I'll show you. I'll just change the color to red so I can see the differentiation. There is a prime implicant in M4 and there is already a prime implicant in M6, right? M4 and M6 will be forming a group just like M2 and M0 did, right? So M4 plus M6 is actually a group. So this is how you form groups with a 3-variable K map, right? In the next video, we'll solve a problem using the techniques we just saw here, right? So we'll just saw actually 2 problems that will be very useful for your exams, end semester exams or whatever the competitive exams you are going for, right? Thanks for watching.